I'll really get up and move from here.
Honestly, right?
I was watching her. And she
Okay, everybody, good morning. Today we'll talk about the endocrine system. This is the last chapter of this semester. Okay, so you should be happy.
Is today our last one?
No, last chapter. But lecture, this chapter might take one more. It will take one more lecture. But today we'll finish the part of the endocrine system. So, you already know that two systems of your body belong to the control systems, right? Yep. The nervous system and endocrine system. Nervous system works first because it works by electrical signal transmission, right? Very fast, quick electrical signal. Endocrine system works through the hormones, endocrine hormones, the glands, okay? We have many endocrine glands in the body, and those glands produce and secrete what? The hormones. Make sense? And then hormones are transported by the blood to the target organ, right? Where it will work. And then the hormones bind with the receptors there and work on the target. So it takes some time, right? Secretion, first production of hormone, right? By the gland, secretion into the blood, blood will transport it to the target, right? And the hormone will work on that target. So it is slower than the nervous system. Make sense? But it is also powerful control system in your body. So now you know that endocrine system works through the endocrine glands that produce hormones. Now, there are two types of glands in your body, endocrine and exocrine. So, these are two types of glands present in our body. What are the differences? The main difference is endocrine glands are ductless glands. Ducts are tube-like structures. Exocrine glands have ducts. So if you see an endocrine gland, this is the gland, these are the cells inside the gland, okay, and these are the blood vessels. We have blood vessels everywhere, you know that, so these are the blood vessels, okay. So these cells secrete the hormones in the interstitial space in between the cells. So these are the hormone molecules first secreted in the interstitial spaces. And from there, these hormone molecules enter into the blood. So the hormone enters into the blood, okay? And blood takes it to the outside of the gland. Make sense? So hormones are first secreted in the interstitial spaces, that means in between the cells, okay, outside of the cells. And then from there, the hormone molecules enter into what? The blood, make sense? To the blood vessels, and blood takes it to the outside. Now you tell me, if the hormone enters into the blood, it should act locally or generalized? What do you think?
What would be generalized?
Should be generalized because blood circulates everywhere, right? So, should it be close to the gland or it could be far away from the gland?
Can be
Far, right? It could be. because once it enters into the blood, blood can take it from the head to the toe, right? Anywhere, far away. So, endocrine glands are ductless glands. Also, endocrine glands secrete hormone in the interstitial space first, and from there enters into the blood. Okay, makes sense? And then we can say that action is generalized. That means widespread. Action could be generalized and far from the gland. All this makes sense, right? So these are the properties of the endocrine gland. If I ask you, give me few properties of the endocrine glands, these are the properties, okay? So secreted into the interstitial space first, then goes to the blood, and action is what? Generalized, and the target could be far from the gland. Make sense? In case of exocrine, if you see an exocrine gland has duct. That means what? This is the exocrine gland. These are the cells inside the gland. And you will see tube-like structures. These are tubes or ducts. There are big ducts, small ducts, right, like that. So these are tube-like structures called the ducts inside the exocrine glands. In endocrine gland, there is no duct. That's why they are called ductless. So what happens, you see, these cells, these are the cells inside the gland, and these cells directly secrete the hormone into the duct or tube, and that tube takes the hormone just outside of the gland like this and releases here to the outside. So the duct takes the hormone to the outside of the gland. Now you tell me, this hormone will act locally or generalized? What do you think? Local, because just where? Outside of the gland. It is released or taken out by the duct, right? And it will act locally. Where? Around the gland. Make sense? Because it's not going to the blood, so it will not go far. Okay? So the action is localized. First we can say secreted into the ducts, and action is localized just outside of the gland here, and target is near target will work on the tissue just outside of the gland. Is it make sense? Okay. So these are the differences. Now if I ask you what are the properties of the endocrine gland, these are the properties. What are the properties of exocrine glands? These are the properties. If I ask you, tell me a few differences, we will write this. Make sense? Okay. I can ask any. Okay. Now, the important endocrine glands in your body. Pituitary gland, which is called the master gland. You know that. So pituitary gland is the master gland located in the brain. Another gland located in the brain, that is called the pineal gland. You have seen the pineal when you dissected the brain. So pituitary and pineal both are located where? The brain. Okay, both start with P. And then if you go down, in the lower part of the neck, here you have the thyroid gland, another important gland. Okay, here in the lower part of the neck. And in the back of the thyroid gland, so this is the thyroid gland, for example. This is the thyroid gland, looks like this. If you see the back side of the thyroid gland, there are small glands, 4 to 8 in number. These are called parathyroid. So this is thyroid gland, and in the dorsal surface or back of the thyroid, you have tiny glands. The number varies. These are called parathyroid glands. Okay. So then, if you go down further, here in the upper part of the chest or thorax, you have the thymus. Thymus is in the upper part of the chest. These two are not listed there, parathyroid and thymus. So write it down. So parathyroid, and then you have thymus. Where it is located? I said, yeah, around here. Okay, upper part of the chest or thorax. Now, if you go down, you have pancreas. Pancreas is located here and placed horizontally like this. Okay, so pancreas. On the top of your kidneys, you have the adrenal glands, also called suprarenal glands. Why called suprarenal? Because located, renal means what? Renal means kidney. Supra means what? Above or below? Above, okay. So, adrenal gland or suprarenal gland is like this, sitting on the upper pole of the kidney. That's why adrenal gland is also called suprarenal gland. So, how many you have? How many kidneys you have? Two. So, 2 adrenal glands on the kidneys. Very important glands, okay? Then you have the gonads. Gonads are testes and ovaries. The male gonads are testes, female gonads are what? The ovaries, okay? So 2. How many ovaries?
2.
2. Okay, so 2 testes are male gonads, 2 ovaries are female gonads. Now, pituitary, the master gland. But pituitary, although pituitary gland controls other endocrine glands, that's why pituitary is called the master gland, but pituitary has a boss too. Who is that? Hypothalamus. So, what happens, you see, this is hypothalamus, this is the pituitary gland, and other glands below that. So hypothalamus is sitting just above the pituitary gland. This is pituitary. Okay. So hypothalamus sends signal to the pituitary, and pituitary sends signal to the other glands of the body. Okay. So that's how the hypothalamus controls the pituitary gland, and pituitary gland controls the other glands of your body. Make sense? So pituitary is called what? Master gland, right? But it also has a master or boss. Who is that? Hypothalamus. Okay? They are very closely connected, hypothalamus and pituitary. Now, the pituitary gland has two lobes or two parts. If this is the front, this is the back, this is called the anterior lobe, anterior lobe or anterior pituitary, and this is the posterior lobe or posterior pituitary. Okay? It has two lobes. Okay. Now, the anterior pituitary produces 6 hormones. How many? 6. Posterior pituitary secretes 2 hormones. Okay? 2 hormones. How the anterior pituitary gets signal from the hypothalamus and how the posterior pituitary gets signal from the hypothalamus, you need to know. Okay? Before that, another thing, anterior pituitary is also called adenohypophysis. Adenohypophysis. How many of you remember hypophyseal fossa? Have you heard that? Okay. Which bone? On which bone you have the hypophyseal fossa? That butterfly-shaped bone.
Sphenoid.
Sphenoid. Remember? On the body of the sphenoid there is a fossa like this called hypophyseal fossa. Which gland sits there? Pituitary. So another name of pituitary is hypophysis. That's why that fossa is called hypophyseal fossa. Make sense? So another name of pituitary is hypophysis. And this part of hypophysis is called adenohypophysis, the anterior pituitary, and the posterior pituitary is called neurohypophysis. So remember, A, anterior pituitary, adenohypophysis. Okay, now let's see what we have. Here you see the location of those glands, endocrine glands in the body. Hypothalamus is very closely connected to the pituitary, and pituitary has 2 lobes, anterior and posterior. Now, how the hypothalamus talks to the anterior pituitary? We'll see that first, okay? So, from the hypothalamus, a blood vessel goes to the anterior pituitary, and here forms the capillary bed. These are capillary, okay, capillaries, and here in this end you also have capillary bed. So this is another capillary. So one capillary is in the hypothalamus, another set of capillary in the anterior pituitary. What happens? The hypothalamus secretes some chemicals here into the blood, and that chemicals are taken to the anterior pituitary by the blood. And this blood vessel is called hypothalamo-hypophyseal portal. Yes. Although the name is very long, right? Name is long, but would you go outside? Yeah. Stay there 5 minutes, then come back. So hypothalamo-hypophyseal portal vessel. It's a long name, right? But it is very easy. Coming from where? hypothalamus, right? Going where? To the hypophysis. Hypophysis is pituitary, right? So hypophyseal. Why it is called portal? If you see in your body, two capillary beds are connected by a blood vessel, that is called portal. Make sense? In your body, if you see two sets of capillary beds, here one, here another, connected by a blood vessel, that blood vessel is called what? Portal. Make sense? So this is how you see hypothalamus secretes chemicals that will enter into the blood, and blood will bring it here, and that chemical will stimulate the anterior pituitary to produce those hormones, anterior pituitary hormones. Okay, that's how the signal comes from the hypothalamus into the anterior pituitary. Now, how the hypothalamus talks to the posterior pituitary? Here in the hypothalamus you have neurons. It's part of a brain, you know, hypothalamus. So these are the neurons, and the long axon of these neurons, see like this, the axons, you already know the axons of these neurons will come here, okay, and will bring the signal from here to here. And the bundle of these axons, you already know, bundle of axons is called tract. So this is the tract, hypothalamo-hypophyseal tract. Same thing, hypothalamo-hypophyseal. Make sense? Going from hypothalamus to the hypophysis. So you see now, when these cells are stimulated, they send signal to the posterior pituitary, and posterior pituitary releases the hormones. Okay, so anterior and posterior pituitary are getting signal from the hypothalamus in different ways. This is by the blood, and this is by the nerve signal. Is it clear? Make sense? Okay, good. So hypothalamo-hypophyseal portal system or portal vessel, and hypothalamo-hypophyseal tract. This is the bundle of axons. Okay. Now, anybody remember how many hormones come from anterior pituitary? 6. Very good. 6 hormones. And posterior pituitary? 2. So you need to know the names of those hormones. Very important, okay? So what are those 6 hormones? Come from anterior pituitary: growth hormone, thyroid-stimulating hormone, adrenocorticotropic hormone, follicle-stimulating hormone, luteinizing hormone, and prolactin. You need to remember those names. And I will mention briefly one function of each. You have to remember that. Okay. First, growth hormone. Its name is telling you, right? What is it? Growth hormone helps in the growth of the body. That is the main function. It works on all tissues, almost all, everywhere in the body, but on 2 structures the action is very prominent, more. Which 2 structures? Bones and skeletal muscles. So growth hormone works almost everywhere, but action is more where? On the bones and the skeletal muscles. Okay. Now you tell me, if during the growth of your body, if the growth hormone secretion is normal, then your body will grow normally. Make sense? If growth hormone secretion during the growth of the body is more than normal, then body will grow, your bones and muscles will grow what? Fast. So the person will be big, right? Big, giant, That is called giantism. Have you heard that? Giantism? Okay. Or gigantism. Same thing. So, increased growth hormone secretion during the growth of the body. That means what? Early part or late part of life? Early part, right? So, when your body is growing, right? If the growth hormone secretion is more than normal, excessive growth hormone secretion occurs, the bones, muscles and other tissues will grow what? First. So the person will become big, right? And that is called giantism or gigantism. Okay? Now you tell me, if growth hormone secretion is less than normal when your body is growing, right? Your body needs growth hormone for normal growth, right? If it is less than normal, then what will happen? The person will grow very slowly, right? And will remain what? Small. And that is called what? Dwarfism. Very good. Okay? Dwarfism. So, abnormal secretion of growth hormone, right, will lead to giantism or dwarfism. But normal growth hormone secretion is what? We need, all of us, we need normal amount of growth hormone secretion during the growth of the body. Make sense? Otherwise, it would be problem. Thyroid stimulating hormone. This hormone stimulates which gland? Its name is telling you. Okay, very simple. Thyroid stimulating hormone. So, it comes from anterior-pituitary and works on which gland? Thyroid gland, here. And it stimulates the thyroid gland to secrete thyroid hormones. These names are very simple. Adrenocorticotropic hormone. Tell me, it will work on which gland? Adrenal gland, right? Why it is called corticotropic? Because when we will talk about the adrenal gland, you remember I said adrenal gland sits on the kidney, right? Like this. So adrenal gland has two parts. Outer part is called the cortex. Outer part is called the cortex. And this hormone works on the cortex of the adrenal gland. That's why it is called adrenocorticotropic. Adrenal cortex. Okay. Now, follicle-stimulating hormone and luteinizing hormone, FSH and LH. These two hormones work on the gonads, testes and ovaries. Work on what? The gonads. Who are the gonads? Male gonads are, I mentioned at the beginning, right? And female gonads are ovaries. Make sense? So, follicle-stimulating hormone and luteinizing hormone, these two hormones work on the testes and ovaries, on the gonads, okay? And help in the growth of the sperm and ova. Prolactin. Yes.
So for the follicle and the luteinizing, is one of them each one, or do they both work on it?
They work, very good question. They both work on the gonads, but their function is slightly different. Both help in the growth of the follicles inside the ovary. When we talk about reproductive system in future, inside the ovary you have the follicles. So the follicles grow, gets bigger, okay, and then rupture to release the egg. Okay. Now on ovary, follicle-stimulating hormone works on the follicles and help in the growth of the follicles. Make sense? And luteinizing hormone mainly works on the growth of the follicle, but mainly works on during the rupture of the follicle, causes the rupture of the follicle that releases the egg. Okay? So you see, both work on the follicles, right? But one mainly help in the growth of the follicle, gets big, 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 and another one suddenly released luteinizing hormone surge. We use the term luteinizing hormone or LH surge. Plenty of luteinizing will be released, and that will cause the rupture of the follicle. So ovum or egg will come out. That is called what? Ovulation. Have you heard that? Ovulation. So these two hormones, you can write it down, help in the growth of the follicles and ovulation, and also help in the maturation of the sperm. Prolactin. Prolactin works on female breast mammary gland and help in the ejection of milk. So after birth, the infant gets milk from mother's breast, and prolactin is released in, plenty of prolactin is released, and that causes the ejection of milk from the mother's breast. Okay, so just know these are the hormones of the anterior pituitary and their actions. Posterior pituitary releases two hormones. One is called oxytocin and another is called ADH or antidiuretic hormone. These two are posterior pituitary hormones. Now I'll mention the function, just one or two functions of each. These are very two important hormones. Oxytocin. This hormone has two very important functions. One is uterine contraction. Contraction of the uterus. Now you tell me, when you need the uterus contract? During birth, right? So oxytocin will be released during the birth, labor, childbirth, right? And it causes what? Contraction, forceful contraction of the uterus, right? That helps in childbirth. Another function of oxytocin is ejection of milk. Now let's go back. You remember I said prolactin? What did I say? I said ejection of milk, right? Change that one. That one should be production of milk. Prolactin helps in the production of milk. Production, not ejection. Production. First milk should be produced and then should be ejected. So production of milk. And oxytocin helps in the ejection of milk. Okay? So these are two important functions of oxytocin. One is childbirth by uterine contraction. Another is the ejection of milk. Now antidiuretic hormone or ADH, antidiuretic hormone. Another hormone of posterior pituitary. Anybody, have you heard that word diuretics? Sometime in the newspaper, right, or magazine you will read diuretics. Diuretics do what? Produce?
Urine.
Urine, very good. Diuretics produce urine. Diuretics could be, pill or medicine, or certain foods also work as diuretics, right? Sometimes if you drink too much coffee, that also works as diuretic. So now you tell me, antidiuretic will do what? Produce milk, produce urine or not produce it?
It prevents.
Prevents. Anti, right? So you know diuretics produce more urine. Antidiuretics will do what? Produce more or less? Less urine. Very simple. So this hormone, antidiuretic hormone or ADH, decreases the production of urine. Is it clear? Okay. So if someone's posterior pituitary produces a lot of antidiuretic hormone, releases a lot of antidiuretic hormone, the amount of urine will be what? Less, very less, right? The very small amount of urine will be produced, right? Now you tell me, if someone's posterior pituitary got destroyed by tumor, so no ADH is being produced, right? Because posterior pituitary has been destroyed. So ADH is not released. So in that case, the person will do what? Produce a lot of urine, right? And that is a clinical condition called diabetes urine volume or production, and that is called diabetes insipidus. Insipidus. Diabetes insipidus is not related to insulin. It is related to the antidiuretic hormone. Decreased production of antidiuretic hormone that usually happens due to a tumor of posterior pituitary. Makes sense? Okay. So that is the antidiuretic hormone. Now if I ask you, antidiuretic hormone should work on which organ? What do you think? To produce, to regulate the urine? Kidney. So antidiuretic hormone comes from the pituitary but works on the kidneys. Make sense? So pituitary is where? In the brain. And kidneys are here, right? So you see the endocrine, I said that endocrine hormones can work far from the gland, right? Blood will bring it from here to here. Make sense? To the kidneys. So that is the antidiuretic hormone or ADH. Okay, so those are the 6 anterior pituitary and 2 posterior pituitary hormones. Now, you remember I said during the growth of the body, if growth hormone secretion is more, that will cause what? Giantism. Remember that? Now, your growth hormone secretion was normal during the growth of the body, so size of your body is normal. Make sense? If your pituitary starts to secrete growth hormone, more growth hormone, after the body growth is ceased or completed, that means in adults, like you are adult, right? Your body will not grow anymore. Now if your pituitary produces more growth hormone and secretes more growth hormone, then what will happen? Your body has no way to grow, get tall anymore, because the bones got ossified. Ossification has been completed, you know, ossification. So the growth plate has been, all got fused. Now in this case, what will happen? Some bones will grow in width, will get broader. It will not get longer, but sideways it will grow more, right? Particularly, it is clear in the facial bones, finger bones, these bones, okay? So that is called acromegaly. So if growth hormone secretion occurs more in adults, that will cause, not giantism, that will cause acromegaly. What are the signs of acromegaly? I said the facial bones are thick, right? Finger bones are thick. So you can look at the face and look at the fingers, you can tell this person might have acromegaly. Is it clear? I told you that growth hormone not only works on the bones and the skeletal muscles, also work on other tissues, but less. So it will make the tongue thick, and the person, will have difficulty in speaking, sluggish or slow in speaking, to move the tongue, right? To speak, you need to move the tongue fast. So if the tongue gets thick, then you can see that the person, when the person talks, kind of slow, okay, and unclear, not clear. So this is an acromegaly patient. See the fingers and face. The face is broad because of the thickening of the bones. So those are some signs. This is a very famous picture. When I was in college many years ago, this picture is used in many textbooks, right? So people all around the world, like in other countries, also know this picture. Many people who study anatomy and physiology. So when I was a student, in our textbook we also had this picture, and this guy is from East St. Louis. Okay, so not too far from here. Okay, he passed away. There is a mural, a statue of this person over there. I didn't go, but I know it. So this is a giantism patient. This is normal. Now, the giantism or giant person, the lifespan is shorter than normal people. Lifespan is what? Shorter. Expectancy is short. Why is that? Because almost all giantism patient or person suffer from diabetes mellitus. Diabetes. This is common. Almost all, okay, of them suffer from diabetes mellitus. And also, I told you that growth hormone not only works on the bones and skeletal muscles, it also works on other tissues of the body, right? So the person's heart will be what? Bigger, right? Liver will be bigger, spleen will be bigger. Make sense? Is that good or bad?
Bad.
We need normal size. We don't need small or big. For normal function, we need what? Normal size. That is simple, okay? So, the giantism people also have malfunctions in other organs of the body, and diabetes mellitus that I have mentioned. So all this together make the expectancy of life shorter. How the secretion of endocrine hormones is controlled. Just know that by negative feedback mechanism. Endocrine secretion is regulated or controlled by negative feedback mechanism. In our very first or second lecture, we have talked about negative and positive feedback mechanisms. Remember that? At that time, I said that most of the functions are controlled by what? Negative or positive?
Negative.
Negative, okay? So your endocrine secretion is also controlled by negative. That means what? First, hypothalamus sends signal to the pituitary. Pituitary releases the hormones. Hormones work on the target. That is normal. So, stimulation is coming from the hypothalamus to the pituitary. Then pituitary releases the hormone that works on the glands, and glands release hormone. Now, when that happens in the blood, the concentration of hormone increases, right? Slowly increases. And when it will reach to a certain limit, then what will happen? It should be stopped, right? Because it is going up, the hormone. So what happens? Inhibitory signal goes to the pituitary as well as to the hypothalamus. Because in the blood, the concentration is now, in the upper limit. Make sense? Should not go any more further, higher. So inhibitory signal will go to the hypothalamus, will tell the hypothalamus don't send signal anymore, okay, to the pituitary. And will also tell the pituitary don't send signal anymore to the other glands, okay. So that's how the secretion will be stopped or inhibited, and that is the negative feedback mechanism. Just know that. We have talked about this. The last thing today, we'll talk about the thyroid. You tell me, I mentioned many times, thyroid is located where?
No, right here. Yeah.
Upper part of the neck or lower part of the neck? Lower, here, right?
It's lower.
Yeah.
Yeah.
Okay. Thyroid gland has two